Hello everyone, my name is Jordan Clayton from Freqs, and today I'm going to walk through how to build your very own blockchain from scratch that will run on your local machine, and it's going to be coded mainly in Python, and we will be using Streamlit as our front end for that. This will be a two-part series. This is the part one of that two-part series, and we'll cut off right around where we start getting into the Streamlit section. Part two, we'll get into the Streamlit coding and actually interact with this blockchain. So if you want to skip ahead to the Streamlit part, feel free. So we're going to break this down into four high-level overview steps here. The first will be to create a new data class, a record data class. The second will be to modify the existing block data class to store record data. The third will be to add relevant user inputs to the Streamlit interface. And the fourth will be to test the PyChain data by storing records. The first thing we need to do is one of the first things that we need to do is get our imports, our proper imports in here. So here I've just copy and pasted my block of imports for this project. We've got Streamlit, which is our Python library that's going to allow us to create web apps. We have data classes, which is a way to create classes that are used to store data. We've got typing, which will allow, it's a Python library that allows you to define the type of data that's stored in a variable. Datetime, that's a pretty standard one. Pandas, we all know and love pandas. And then hashlib is the library that is going to enable us to use our hashing functions for the blockchain. And then, of course, NumPy. So now that we've got our imports all situated here, we're going to start with our new class record. So in front of our new class record, we will add the data class decorator. If you are not familiar with what a decorator is, I pulled this up for a quick representation. The data class decorator is used to automatically generate special methods to classes, including strings and REPR, which stands for return printable representation. It helps reduce some boilerplate code. So it's essentially bootstrapping our function with some added functionality, reducing some of our code here, making it a little bit more elegant. And now we're going to define our new class record, and we're going to give it some attributes. So sender, and that will be of type string. Receiver, and that will also be of type string. And then we're going to have amount, which will be of type float. Now that we've got our class record defined, we're going to go ahead and define our block class. So again, we're going to wrap that with our data, not data class block. And we need, there we go, colon. So now we're going to give it some attributes and set those attributes equal to set their data types. So record, that will be of type record. Creator ID will be of type int. Then we've got previous hash, which will be of type string, and we're going to set that equal to 0 at first. Previous hash will be 0 because there are no hashes in the very first one. Then we've got timestamp, which will be of type string, and then there's a bunch of formatting that I'm going to paste into here so I don't mess up and have to debug later on. And then we've got nonce, which will be of type int, and that will be 0 at first. So the nonce stands for number only used once, and we're setting that equal to 0 now. The nonce will update every time the block updates, which will prompt since it's in the block, every time that number changes, the hash will change for that block. And now we're going to define a hash block function. So this function will be responsible for a lot of the heavy lifting of actually encoding and hashing all of the data within each of our blocks here. So let's define hash block, and we're going to pass the self parameter through there, and that is going to tell the function, it's going to refer it back to the class that it's nested within. All right, and then we've got our SHA, hashlib, SHA-256. That is our hashing function. Then we've got record equals string and self dot record dot encode. So what we're doing here is we are saying to look at the record attribute of the block class and then encode it. So look at the record attribute of the block class, that's self, referring it back to the block class, and then encode that with the encoding function. So we're going to do that with all of our parameters that we add into here, or attributes that we add into this hashing function. So we're going to repeat this several times now, and you'll start to get a flow here. We're going to update the encoded record data with the hashing function, and we're going to do that by sha.update record. All right, then we need a creator ID, which will be a string self.creator ID dot encode. So you see that we're starting to develop a pattern here, and then we sha.update creator ID. Okay. Next we need our previous hash. That will be string and then self dot previous hash, again, dot encode. And our pattern continues. Again, sha update previous hash. Okay. Next we've got our timestamp. That's what we need next. Timestamp, which will be string self.timestamp dot encode. And then we're going to sha.update timestamp. Okay, now we've got our nonce, our number only used once, string, and then self.nonce dot encode and sha.update nonce. And then finally, we are going to return sha.hex digest. So hex digest is hex digest here. This hashes all the block class attributes. So this is going to rehash everything every time that one's ran. Okay, so let's just summarize this block of code here because there's a lot going on, and I think it's worthwhile kind of trying to bring it all together. So we're defining the new hash block. We're passing the self parameter saying you're going to be looking back into the block class a lot. And we've got our SHA variable that we're setting here. We're setting that equal to the SHA-256 hashing function from the hashlib library. We've got record variable. We're saying this is going to be a string. Look into yourself and find record and then encode that. Then you're going to take what we just defined here, our SHA-256 hashing algorithm, and you're going to update record. You're going to update that with the hashing function. You're going to do that with all these other variables until we get down to here, and then we're going to say return SHA hex digest, and that stands for, I think, hexadecimal, and then digest, which is a different function within the hashlib library. And so this is going to return the full hashed function that's got all the encoded data that we put in front of it contained within. Okay, so now the next class that we're going to create is going to be our PyChain class. This is a really cool one. I think these are all really cool, but the PyChain class is where we're going to actually set up the algorithm that's going to validate the integrity of the blockchain that we're building here. So we're going to use our data class decorator once again, and we've got class. We want to do PyChain class. And then first attribute we're going to add is chain. So our chain attribute will be a list of block objects. And then we've got difficulty, which will be an integer equal to 4. So that's just going to be the default difficulty level. And the difficulty level will be how hard is it to solve for the hashing function that will be the winning hashing function to allow the creation of the next block. Okay, so now we're going to define our proof of work function within our PyChain class. So define proof of work, self, and block. So what we are saying here, similar to how before, self is referring it back to the class that it's nested within. Self is now PyChain, and block is referring to this previous class block. So this is equivalent to saying PyChain, comma, capital B, block. All right. Calculated hash equals block dot hash block. So here we're saying the calculated hash equals class block and then hash block, all this stuff. And num of zeros equals 0 times self dot difficulty. So what we're actually saying here is, I know you normally can't multiply by 0 anything, but this is a string and not an integer. So we're saying that we want self dot difficulty. So we go back into our PyChain, our difficulty, so whatever this is set to, which is currently 4, is what that will be multiplied by. So we're saying that the winning hash block needs to have however many this number is, so right now it's 4, needs to have 4 leading zeros in order to be the winning hash block. So now we're going to add a while loop here. Start with num of zeros block dot nonce add 1. So what are we saying? We are saying while the calculated hash here does not start with the number of zeros specified here, add 1 to the nonce. Every time we add 1 to the nonce, the hashing function gets updated. So that's changing every time. As long as that's not satisfied, updating until we get that right one, then that one becomes the winning hash. Okay. And so calculated hash equals block dot hash block, and print winning hash, and then that's the string. It'll give us that string and then let us see what the calculated hash actually is, and return block. Okay, so this next function is going to be where we add the next block. So we're going to define add block. I am backwards. We're going to pass self through there and then candidate block. Okay, and then block equals self dot proof of work, and then candidate block. So because we're going proof of work, candidate block is going through proof of work, hash block back up through, all the way back up through the block class. And what am I missing from my definition there? Okay, so block, and then we've got self dot chain is, and then we pass block backwards. Okay, so self dot chain, which is our list of blocks, and within our list of blocks, block objects, we will be adding the block, which is our self, and then our proof of work, and then our candidate blocks. This last function that we're going to build into The PyChain class is going to be the validation function. So this is how we're going to validate the entire blockchain here. So we're going to define is valid, pass self through there, and then we're going to say block hash equals self.chain 0 and then hash block. So what we are saying here is go into the chain, which is a list of block objects, and grab the very first result of our hashing function, our hash block function, and that result is the full hash function with all the data encoded within it. So that is our hashing function. So go in there, go in that chain, grab the first one, and that's our block hash. Now, for block in self.chain 1, so what are we saying? We're saying for block in the chain index at index 1, if block hash does not equal block previous hash, print blockchain is invalid and return false. Okay, so now we're going to set the block hash value equal to the hash value of the current. So block hash equals block dot hash block and print blockchain is valid and return true. Now we're going to actually demonstrate how this blockchain works, all this work that we've been doing here. Now, part 2 is going to cover how we actually code this into Streamlit, which is going to be the front-end application, the front-end web application that we're going to use to actually interact with our blockchain here. But again, that's going to be for part 2. And I don't want to leave this video without demonstrating after going through all of this and coding all these lines. I gotta show something for all this work. So we'll demonstrate it with Streamlit, and then round 2, we're going to come back and we're going to show how we actually got this to operate within Streamlit. So first things first, you got to make sure that you are in the directory that your Python file is actually located in. So I am there, and just to be sure, there you are. That's my file that we did all of our coding in right there. And you also want to make sure that you're in the proper dev environment if you've got a dev environment installed. So for me, we're going to go conda activate blockchain dev. All right, now we're in there. That's got my Streamlit pip install, and you're going to have some other installs that will be required for this to work properly. So, all right, we're in there, and now we simply will run Streamlit run pychain.py. Okay, you could just copy and paste that into your browser, but mine automatically loaded in there. So let's get our terminal open at the bottom and our Streamlit open here at the top. All right, and so now you can see, so all this stuff we're going to go through in video 2. So all these buttons, this slider here, this text field that we enter in here, the button here, the sender info, all this stuff we're going to code in video 2, the whole thing. But for now, let's just see how this operates. So here you've got sender info. So let's just do something generic like sender 1, okay? And then we're going to do receiver 1. Great. And then we're going to just do an amount of 1. Let's just do it super generic right now. And let's add the block. And we get balloons. That's great. And we actually, we'll show you how to do the balloons and everything. And down here, now you've seen initializing chain, and we've got a winning hash. And notice our beginning difficulty level on this slider here is a 2, and here we have 2 leading zeros in our hash function. So remember all of that coding that we did into the hash function. There you can actually see it working. So let's go ahead and let's update our information here, and let's do another transaction. We're going to go to 2, and let's add that block, and boom, more balloons. Most important. Second important, we've added stuff to the block, and there you go. And creator ID is in there. Great, great, great. All right, and now let's go down here. We see another winning hash, 2 leading zeros. We did not change the block difficulty. Let's crank it up to 5, and let's move it to 3, sender 3, receiver 3. Great, and we'll do an amount of 3. Add the blocks, never get tired of those. And here we go. There's our transactions, looking good. Winning hash down here. And now you'll also notice we've got 5 leading zeros as we've increased the difficulty of that. Okay. And if you want to look at any specific block in the chain, you can view that in the inspector here that we've got. You've got the creator ID, the record, previous hash, and the timestamp and what nonce that it finished at. There you have it. You just built a blockchain from scratch in Python. You'll be able to interact with it fully after you watch video 2, and we go through how to code this PyChain ledger stuff into there. But you've got the foundation done, and the next one's coming, so you'll be able to celebrate with balloons on your screen and build an actual blockchain on your computer for whatever reasons that you decide that you want to build a blockchain from scratch. Once again, my name is Jordan Clayton from Freqs, and if you found any of this content useful, please like, subscribe, share. We're a super small YouTube channel trying to produce high quality content, highly detailed content on how Web3 applications are developed.